Gonna introduce myself again. So my name is Candace. I'm in K.O. Knutson Middle School, and I'm going to Clark High School this fall. So this experience is a fact check challenge. It's design a test to see if you can make the same thing happen as in the video on Coke and Mentos suit. And here is the video.
Sometimes you say things and then they actually happen. Oh, yeah. Wow. We said we would put Josh in a Mentos suit. Here he is now. I'm nervous because I don't want to lose a friend, but at the same time, I won't see you explode into the sky. All right. Ready. Go, Josh. Sweet shot. You're done. You want to try. There he goes.
Now, none of these guys are athletically inclined.
Hit this.
So these balls are flying everywhere.
Nice. That's a good one.
I'm the least athletic one out of all of us. I could barely throw a ball properly. Like, there's no way I'm going to be the one.
Hey guys.
Dave hits the ball onto the plane, and there's 1 nanosecond. I see Josh. He locks eyes with me. We're looking at each other. We're both like, really? Dave made the contract?
I'm the space monkey of epic meal time.
Oh, that was exactly what I wanted to have happen.
Are you okay?
People ask me, what if Josh had died? I'm always like, I don't know. What if? What if Josh is actually living for the first time ever now, thanks to being Mentos Man?
So in this video, there's a guy with the Mentos suit that went into the tank of Coke. And the science behind this reaction is that the Mentos induced rapid escape of CO2, which is dissolved carbon dioxide in the liquid, changed into a carbon dioxide gas, and might have escaped from the tank of Coke. A carbon dioxide is CO2 is colorless, odorless, and is solvable. It's soluble in water. And carbon dioxide consists one carbon atom and 2 oxygen atoms. It's a non-polar molecule, meaning other molecules won't stick to it easily. H2O, water, consists 1 oxygen atom and 2 hydrogen atoms, is a liquid and is a polar molecule. Uneven distribution of electrons results in sticky spots, areas where molecules form weak bonds. Water is a liquid. Carbonation occurs when carbon dioxide dissolves in water or in a watery solution. Under everyday conditions, it's common for carbon dioxide to dissolve in water. Under increased pressure, more carbon dioxide is dissolved in water than would be possible under normal pressure. More carbon dioxide, normal conditions until the mixture is supersaturated. Water molecules squeeze in and from cages around the carbon dioxide molecules. Carbon dioxide is trapped. When temperature is dropped, the activity of molecule slows. The hydrogen bonds become stronger. Carbon dioxide can't break the water chain and retain in water. Under increased pressure and low temperature, water molecules can trap lots of carbon dioxide molecules. When the bottle is sealed, the carbon dioxide is kept in watery solution by the bottle's pressured conditions. The inside of the bottle maintains increased pressure to prevent the extra carbon dioxide molecules from escaping inside the bottle. Carbon dioxide exists in 2 forms. Some carbon dioxide dissolves in water, and some carbon dioxide sits in a gas between the top of the bottle and the liquid. In every sealed bottle of Coke, dissolved carbon dioxide and gaseous carbon dioxide is this, in equilibrium. A closed bottle of Coke is equilibrium, but when we open it, all of a sudden we no longer have equilibrium. A sudden pressure reduction results in the carbon dioxide in the headspace of the bottle escaping into the atmosphere. When the bottle is left out in the open, carbon dioxide continuously escapes. However, carbon dioxide escapes slowly. Eventually, the Coke will go flat. That means concentration of dissolved carbon dioxide gets lower. If in a wide-mouthed jar, carbon dioxide will escape quickly. If in a bottle with relatively small mouth, from which carbon dioxide gas can escape less quickly. A carbonated beverage, Diet Coke, is packed full of dissolved carbon dioxide, which forms bonds with the water. When Mentos are dropped into the Coke, Mentos help break the carbon dioxide bonds with the water. Mentos have rough surface, which provides nucleation sites for the dissolved carbon dioxide to form carbon dioxide gas bubbles. The swift formation of carbon dioxide gas bubbles pushes the Coke upward and out of the bottle, causing the jet of Coke spray. My hypothesis is that the rapid escape of carbon dioxide causes the dramatically impressive reaction of the Diet Coke and Mentos. Variables. Possible independent variables are pressure, temperature, number of Mentos, amount of Coke, speed of falling through the solution, way of dropping Mentos, and etc. Independent variables we're interested in is Mentos induced escape of CO2. Independent variable is the rate of eruption in terms of spray height and etc. Control variables are temperature, number of Coke, number of Mentos, way of dropping Mentos, and etc. For experiment 1, materials are 2 bottles of 500 milliliter regular Coke with the same expiration date bought from the grocery store. 4 discs of mint Mentos out of the 14 discs in a roll. Procedures are let 2 bottles of 500 milliliter regular Coke sit outside at 82 degrees Fahrenheit for 20 minutes. One closed and the other opened. Get 4 discs of mint Mentos out and prepared. Drop 2 discs of mint Mentos into the open bottle and drop 2 discs of mint Mentos into the other bottle immediately after opening it. Here's the video of me, one of the trials of me doing it.
Ooh.
So this experiment shows that the spray height of the unopened regular Coke has an average spray height of 6 centimeters, and the spray height of the open regular Coke has an average spray height of 5.5 centimeters. In the experiment 2, materials are 2 bottles of 500 milliliter Diet Coke with the same expiration date bought from the grocery store, 1 wide-mouthed glass container, 4 discs out of the 14 discs in a roll of mint Mentos bought from the grocery store. Procedures are pour 1 bottle of Diet Coke in the wide-mouthed container and let it sit outside at 85 degrees Fahrenheit for 20 minutes. Let 1 bottle of Diet Coke unopened sit outside at 85 Fahrenheit degree for 20 minutes. Drop 2 discs in the wide mouth container and drop 2 discs in the bottle of Diet Coke immediately after opening it. Here is the video. So in this video, this experiment shows that the spray height of the unopened Diet Coke has an average spray height of 8 centimeters. And the open Diet Coke in the wide mouth container almost has no reaction, no spray heights. So the results are experiment 1 shows that carbon dioxide escapes very slowly after the bottle of regular Coke is opened, but still kept it in its original bottle for 20 minutes. We don't see much difference between the spray height out of the opened and the unopened bottles of regular Coke. But for experiment 2, it shows that after pouring the Diet Coke in a wide mouth container, most carbon dioxide escapes and only a bit was left, and therefore we don't see eruption. From 2 experiments, we can see more Mentos induced to escape carbon dioxide causes more dramatically impressive eruption. The conclusion is that the results of the 2 experiments shows that if the carbon dioxide in the big tank had been escaped, then the explosive reaction in the video should be